Welcome everyone to the 3D Experiencers Construction Tribe session number 4. Uh, Thank you for taking the time out of your day to meet with us. I think this is going to be a very exciting session because it's not going to be DS Dassault presenting anything or something. We have the incredible CAD makers showing recent work on the world's largest mass timber building. Other than that, I'm not going to drag this introduction out very long. I'd like CAD makers to get right into it because we'll have more time for questions at the end. So uh, we've got Nick, we've got Javi, we've got Ryan. You guys want to take it away?
Jonathan, can you guys see the screen?
We've got it on. Yeah, we've got it here.
Okay, so I'll dive into it. So just we got a lot that we're going to try to get through in a short period of time. So thanks for the introduction. We'll try to just get into it real quick. It's really laggy, I think. So I'll try to accommodate the lag. So the first thing we're going to talk about at a high level, we'll start in just a quick couple slides just to give context, but this is a 18-story mass timber hybrid building. Why is it so, you see this? What's going on? It's very, very, very laggy. Okay, so you got 2 concrete cores, a transfer slab at the podium, 4-foot deep transfer slab, and then the rest is cross-laminated timber slabs with glue lam columns and steel connectors between the glue lam columns, and then a steel decking roof. And so just to give you a little bit of context here, I'm going to dive through a couple slides just to talk about the process, and then we'll get straight into some CATIA stuff. So originally, what can you guys see? Do you see a...
I see a glue lam column to concrete.
Okay. So sometimes the videos and stuff don't work, but early on it was kind of, we did a mock-up was the first kind of proof of concept that it would work. So we had to, we're using the model, we're using Delmia to simulate this mock-up to analyze 16 different connection points. There was wood-to-wood details, there was different types of steel connector details. The concrete to wood was a detail we tested. So early on, we were using Delmia to do a digital mock-up of the installation of this mock-up. And right in the room with the builder, pretty quickly it became evident which detail people like the most is actually the steel detail on the left, because it has a tube in the center that helps as a self-leveling aspect for the panels as they come in. And that ended up winning. Actually, when they built the mock-up live, they're about 60% ahead of schedule, what they had originally planned. So it was a good first step. I'm just going to fly through this. So this mock-up was the first time where we were able to test. Are we really going to be able to build the structure as fast as we hope? Because there's a premium on the materials of the product. Mass timber is a little bit more expensive than concrete for an 18-story building, but if we can make it up on speed, overall net, it's a strong performa for the owner. Some details from virtual to live. The full building structure, like I said, 2 concrete cores, cross-laminated timber, and steel connectors. We have every screw, every nut, every bolt, every component in the model. Not necessarily practical in every project, but in this case, these screws are engineered in Germany, and they're like $2 a screw. So it was material to the cost of the project to have these types of components, and it ended up being beneficial down the road from a digital fabrication perspective. So we did everything, and the full building was done in one central CATIA model, all elements. MEP as well, which we'll get into. And then we did selective prefabrication on the MEP systems, which we'll get into as well. Identifying issues as we go. We don't have to do that much. So the first floor is there. Transfer slab, we didn't do the full reinforcement of the building. We just used, we wanted to identify where the canning locations were going to be relative to the embeds needed for the bottom of the columns. So we were looking at, we used, just did the rebar in the 4-foot deep transfer slab bands, and then the slab rebar for coordination purposes mostly. Walls above, encapsulation layers, and then there's kind of a full detailed floor And there's a lot of iteration with the trades to make sure we're plumbing it the way that they want to plumb it, and optimizing it into 2 bathroom groups so we can, you know, help with prefabrication, both of the wood but also of the plumbing systems. So I'm kind of flying through here. This is all the elements that went to the fabricator by giving a step file from our CATIA model directly to fabrication with all the riser penetrations located. We're able to also take the MEP side of things with those risers and spool it or do assembly drawings from those pieces. So we're able to deliver to the MEP contractor a fully coordinated, you know, bill of materials with everything, and then the actual live plant. Okay. So there's kind of how it looked live. And then, you know what, we're just going to stop here and dive into some models. So I'll pass it over to Ryan.
All right, thank you. So we'll jump into the model here. We have quite a few things loaded here in multiple sessions, so forgive us on the speed.
What's going on? Maybe do the mod.
It's really kind of hard to tell if it's the connection that's lagging or your model that's lagging, so I wouldn't worry too much about the speed.
Okay.
Okay, so to give you guys some context within the model, this is the full mod, or the full structure module. I've shown the drivers for the MEP. So we use a surface sock to cut out all the penetrations, and then we link, and I'll get into a little bit more detailed once we show the mod, but we use these drivers to drive the MEP and connect that to a master sketch, and then all of those elements are linked to the driver, so if the driver moves, the holes move, and subsequently all of the mechanical components for the plumbing move as well. So to give you an idea of what that looks like on a smaller module, because it's a little bit more time consuming to update with such a large model, we'll do it with this.
So maybe I'll chime in too. What we did here, as we said, this was largely a prefab project, kit of parts, prefabrication, I guess is the best way to describe it. With the structural engineer, we did a little, you know, what if scenario if we were to do this in modules. So take essentially a unit, this is a studio unit, and turn it into a module of sorts. What would it look like? So, and then for that purpose, we can do this exercise here.
And to give context into this little exercise, what we did is we basically took a bay out of the Tallwood project and made each studio unit kind of like a prefab module type of mod essentially, that we could reuse the elements and kind of take the idea of like, what if we could make this modular. So we in this building we have the prefab spool as well as UDFs for each of the stud walls, and then the plumbing fixtures as well that we've inserted. So if I update, for example, the width of the room, we have a wireframe that drives all of the walls and all of the individual stud walls and locations of the columns. And then with the sock, we've essentially linked all of these plumbing components to, and I'll have to show you in the next update, but we've linked all the plumbing components to a sketch based on the location of the shower, the location of the plumbing sink fixture behind this wall, and the toilet. So as the walls move, so do the fixtures, and because we're using cylindrical, or actually point-to-point connections for those fixtures, the plumbing and subsequent piping move as well. So once that updates, I'll do an update on the bathroom.
Can I ask a question while this updates?
Sure.
What do you do if you were to place one of these modules next to another module where you would have columns overlapping?
Yeah, so obviously Jonathan's probably the first person to ask us that. Don't test us on a structural. We honestly, it was just for demo purposes. It's not really meant for fabrication, but yeah.
The way we would handle that, though, is as you can see here, the columns didn't move. It's its own assembly. So say we were given through FEA or whatever from the structural engineer, here's where the locations of the columns need to be. Let's try to find the most optimized way to make it modular. We could have that as its own assembly within the master assembly that could be updated separately if needed. So, you know, maybe some modules have columns in the middle of it potentially, right? Or, you know.
Yeah, we would really have to rework the structure in terms of lining these up so that they can share structural column entities, because we really just kind of put it together really quickly to show the modularity of things moving together and how you can have all of the components in one smart model versus the actual constructability of I guess bringing these mods together and having them share column connections. So it's a good point. You caught us there, John.
Well, you know, you could just parameterize it too. Give it a right, left, or north, south, or whatever column creation or non-creation parameter.
Yeah, so I don't know if you guys saw there, we had also a QA/QC check. It's basically just a rule where you can define, and I'll open it up after this update too. It's basically a rule where you can just define either a max dimension or some sort of, whether it's a max dimension or an if statement, where if you exceed a dimension or you activate a certain parameter, it'll return a pass or fail. So in that case, I just said if the width of this unit exceeds, I think it was like 4,500 millimeters, it's going to give us a warning that we're actually exceeding the maximum allowable dimension of a flatbed truck. So that returns a little red or green light, and it's not very useful in a single physical product like this, but if you were using a knowledge pattern to instantiate a bunch of these, a product template and knowledge pattern to instantiate a bunch of these different modules, and it was based on just profile outputs, then you'd be able to instantiate all of them quickly and then have a check to verify based on your internal code compliances or quality assurance checks that you're within certain parameters or within certain design parameters. So, man, this is taking much longer to update than normal. But yeah, so as you can see in the background, the windows are also updating because it's linked to these connections. So we use a lot of engineering connections when we're doing parametric modeling with in-context components. And it's normally this is pretty fast, to be honest, but it's normally faster than this, so it's working quite well for us. Also, another thing to note about these these stud walls, is that they're actually a UDF driven by a single line input. This is, I believe, our first or second iteration of the Drywall tool. I'm going to show you guys our iterations moving forward and how we've improved the tool a little bit. And it's I think you guys can use these methodologies moving forward in your own process if you care about stud walls, because it's been quite helpful for us to just filter the wall types and really reduce the amount of manual modeling that's required to actually generate this content, generate this geometry.
Yeah, as it's changing, all the quantities are updating too.
Yeah, so once I...
Hey Ryan, are you using assembly pattern for the stud walls?
For the stud walls, no. We actually have a sketch that has different center lines for all of the stud walls, and then we use a UDF, so a user-defined feature to select that line, each of the center lines as an input of that UDF. So when we adjust the overall length or width of the mod, the wireframe changes as well. As you can tell, there's kind of a few issues with the directionality of the line. So sometimes the direction of the line will move, and because of that, we actually our offset of the jip there kind of messed up. So I have to reverse that. So there are a few limitations with the tool, but overall, it's much better than actually modeling the wall itself, or having just a extruded extruded pad representation instead. So it's actually still a lot better in most cases. So to kind of visualize and answer your question, what it is in this case, this drywall tool has a door as well, so there's actually two inputs, but show some lines here. All it essentially is a line input and then another line indicating where the door is. So from that we can generate the studs with the jip, as well as each of the individual tracks as well. And then we have parameters for the quantity takeoffs of the lengths of each of the studs and the area of the jip. And I created a report that what we'll do is we're going to package this module, the tallwood structure that you guys saw, as well as the simulation that we're going to show in a few minutes here. We're going to package that onto the Tribe common space, or not the common space, sorry, one of the collaborative spaces for sharing, and you guys can go in and actually dive into how we set up the drivers, how we linked all of the mechanical plumbing components together. So it gives you a little bit more context, because I'm going to explain it, but it's much easier if you guys are able to see what we actually did and look at it for yourselves. So and in that as well, you'll have the drywall tool that we made, as well as a few other of the UDFs that we can embed into that model. So you guys are more than welcome to have a look at that. And
that's very generous. Thank you. Yeah. Another question. Do you guys ever get into laying out the drywall based on the stud configuration?
Laying out the drywall. Sorry, didn't catch the last half of that.
Based on the stud configuration. So you based on the stud spacing and location.
We're actually doing it right now. So the next project, what we're going to show at the end, kind of the iteration of this tool into a more of a batch process, but that's what we're doing, all the canning for this like twisting tower with the drywalls as per like the stud spacing, thickness of stud. And it's nice because the tool's built to have all that in custom, so you can just toggle on back and forth the distance between studs and the thickness of the studs. So you can do it at the global level, or you can go in one by one and change it if needed.
That's great.
I really wanted to show the mechanical moving, but I think another update is going to be too grueling for some of us CATIA users. So I'm going to jump into the simulation for the formwork that you guys were beginning to see. If I can switch apps, switch sessions.
Why don't you just show the dummy mod?
Still updating. Sorry, it didn't seem to load in our last. We had to switch computers really quickly, so a few of the things got lost, but show the update for this once this updates. But what we'll show instead is the assembly sequence for the module. So actually this CM mods kind of proof of concept that we did, we created a little demo for simulation, just like a manufacturing sequencing of each of the of this mod coming together in a manufacturing context. And by doing this, it actually brings up a lot of interesting questions for how you lay out your deck, the sequence of things coming in, and then obviously the trajectories at which they come in. So it's actually, we found this tool really good for visualizing things coming together. Of course, it's reusing some of my older components, so the mod is not fully updated. Sorry, we were reworking a few things in this mod for the demo, but I guess it didn't update quite correctly. But essentially, you can see how each of these components comes together. And what's nice about doing it in a manufacturing assembly context is that you can quickly, traditionally, if any of you guys have worked in Delmia, what you'd have to do is create a PPR context for this overall product, and then create manufacturing items and basically an MBOM and a process structure before you can create this assembly sequence. And that's just kind of the methodology that Dassault has kind of taught us. What we were able to do is create this quick assembly sequence by just selecting each of these components or each of these sub-assemblies and applying trajectories to it. And I think most times in a construction scenario, you're really just trying to put things together and see if there's any clashes in a trajectory or installation context. So being able to quickly just generate an animation or generate an assembly sequence really helps with that. And also what you can do with this scenario is do 4D clash. So not only do you have the 3D clash, but the 4D associated to the time and the trajectories of each of these elements coming together. So I'm going to stop that there, and we'll dive into the nitty-gritty of how we set up those drivers and how we linked each of those mechanical components to the overall assembly.
You put your drivers at the bottom of the tree.
So this this structure all levels product normally actually doesn't have any drivers, but for the presentation I had to insert them just so you guys can visually see them. We worked in this case we worked in multiple work models. So we actually have a structures work model with actually just, it's actually this one right here is one of them, and it has just the typical floors in it, and each of these typical floors is kind of each of these typical floors is duplicated up, so we really only had the bare necessities in this model. So Nick actually wanted us to show a video about kind of the methodology of creating this, and how we originally designed it in the traditional CATIA sense, where we had every single because of manufacturing, we needed each reference part to be a different name so that they could reference it for their CNC. And because of that, we actually had duplicated the 3D geometry for every single part. So in the nth hour, we kind of had to reconfigure and make the product a little bit more usable from an updating perspective, just because it was taking an hour per floor to update originally. So we created this kind of driver's relation with each of the floors, and then used copy paste with link for all the typical outlines and profiles of the wood. And then inside of each of the individual floors for the typicals, we would detail it out based on the MEP for that floor. So it actually helped a lot with the updating of the model and being able to change it. So here's kind of an overview of the drivers. So we have global parameters and the grid and the sock. So the socks are all of the mechanical penetrations and the outer sock of the envelope. So we use the sock to cut the overall profile of each of the panels as well, and then the grid spacing drives the bays of the structural columns as well as the connections of the CLT panels. And then you have global parameters for things like the slab thickness, the floor-to-floor height, so on and so forth. And all of this is linked to all of the structure and mechanical is linked to all of these overall drivers. So here's just the master sketch for the MEP envelope. This is the HVAC shaft. And it's pretty typical, but what we're doing here is just modifying that HVAC shaft location and then updating this assembly after we make a few more modifications to the grid.
We had to do it at the end because of the penetration's open, right?
Mm-hmm. So, yeah, so the reason why this was, we built it this way is because it makes the modifications at a fabrication level much easier to manage and actually make those changes and implement those changes, because you essentially have one master sketch driving the entire model and the geometries of the entire model. So we could just make a change at the master sketch, and it would propagate to all the floors and all of the panels, and obviously the mechanical and all of the linked entities would move as well.
So you were constraining everything to the grid?
Yes.
Even the mechanical?
Yes. In every case where there's a penetration or something linked to the structure, if it's something that's specific on the floor, we didn't really worry about it as much. But when it came to wood penetrations for the risers or the sanitary drainage, we linked it so that we could make a quick modification to the risers or the location or the size, and it would propagate to the subsequent kind of plumbing penetrations as well. So now we've made a few modifications to the drivers. We've shifted a grid line, moved one of the penetrations for the HVAC mechanical assembly, and now we're just updating the master level. So essentially each panel has the same outline, same profile. So we were able to update level 3 and level 9, 10, and 18 would update as well, just for the profile. And then we had another level of modification where, based on the penetrations, the center of gravity of the panel would change. So we would have another UDF that has an input of a surface. So we'd select the bottom surface of this individual panel, and then based on some parameters, it would create the lifting lug locations. So those squares with the circle in the center indicate the lifting lug locations, and that's for, it was helpful for just like safety and the ease of connecting and inserting those lifting lugs.
Yeah, and it came up in the simulation part too, where we used Delmia to work through the whole installation process, where the whole thing with this project is speed. So they didn't want, every time they got to rig a panel on site to try to find the most optimal place to rig it. That we wanted to give all that information so the panels come off the truck as fast as possible under the crane, and they get thrown into place like a Lego kit.
And so you had multiple contexts where you were updating the almost the first level of control geometry and then the second level of dependent geometry, so that the model was partitioned in a way that you could update it quickly.
Yeah, essentially we would update just the typical floors, and then it would propagate to the other contexts once we open those models, or we jump back and flip back to that next tab. So yeah, you're exactly right. We were in multiple contexts to quickly update. And then on top of this, we also, for fabrication purposes, we needed to have a specific nomenclature for each panel. So we used scripts and copy paste with a link, like I mentioned earlier, to regenerate the content for each typical floor with its specific nomenclature. So here's the inputs for that renaming script, and then there's also a script there for copy paste the surface and the body, and then that's essentially how we created all of the manufacturing models, because we tried to do it manually and it was going to take too long, so we had to script it this way. So the last thing was renaming, not particularly that interesting. So
and we'll put this video up there too.
And we'll put this video inside our blog post as well. But ultimately, the reason why we're doing all of this for the fabrication model is so it can go out to a CNC. So the end output was a CNC step file for each of these panels.
How much repetition was there between the panels?
There was quite a bit. I mean, 3 to 8 is typical, and then 9, there's the way they designed the risers, there's no penetrations at 9, so that was a different floor. And then the sizes from 9 to 17 were different in terms of the penetration, so they were slightly varying in that sense as well. But I think there's overall, I want to say 54 different panel types.
6 floor times 30. 6, like, where are they located? So the view right is still more than 50.
6 times 50. 300 different panel types.
We're debating internally how many.
We'll let somebody on YouTube check your math.
Yeah, exactly.
I'm not going to check it now.
So,
it's Bertrand speaking. I have a question about how do you manage tolerance to make sure that once you're on site, all the panels they go together well? I mean, if it's cut exactly at the dimension, is that really okay to assemble like that?
So the structure lab did QA. So the fabricator was still responsible to generate, basically for the big building, we gave them a step file. They recreated shop drawings from our model, and we reviewed it with the design team to make sure it was going to work with the rest of the building. And they actually did QA/QC on every single column, I believe, which they said that they did the more QA/QC on this project than they've ever done. So they were still, they were doing their own internal tolerance QA/QC before it left the shop.
Okay, yeah, I understand. Thank you.
And in our model, we oversize, for example, we oversize all of our holes, obviously. So there is a level of those tolerances in there, but again, it's up to the manufacturer to verify the geometry to make sure that everything's going to fit together in.
Well, the geometry was CNC put a model. They didn't do a model. It's just that they have tolerance. The project has to plus 2- mil of tolerance. So
Plus or minus 2 mil?
yeah, they had to verify that everything was inside this.
But you guys then were verifying the actual drill holes to check that they were within the tolerances of the oversize for the bolts? Or were those dimensions given to you?
The dimensions were given to us.
Okay.
Most of them.
Most of them.
Yeah, some stuff we had to make it work.
Yeah.
But I mean, the long and the short of it is, we'll get into it, but obviously this is the first time this building's ever been built, and everyone was collaborating for sure. But I mean, they built 17 stories in 9 calendar weeks, and the general comment back was everything just went together really well. They just flew up the building. They're at the end of it. They were close to 3 floors a week output, so they actually improved as they went up the building in terms of the actual production.
They could have gone faster. They got stopped by not planning for the stud. So the structure stud, I mean the inside wall stud was the one that delayed the whole project, just because that was the only thing that was not prefab, was done the typical way.
The walls.
And then for code, they had to close the building, so they actually had to slow down for them.
Sure, mechanical.
Are they prefabbing the interior walls in the next iteration?
We actually have another one we're just starting, and that's our kind of recommendation so far, is to try to find a solution where the wall is fabricated with pipes in it and maybe one level of gyp off, so the inspector can the plumbing code inspector can review on site, but at least you just have one side of gyp to close off. But I mean, there's a tolerance on the top track that I think is a challenge if there's a slab above when you're installing. But I think that's the idea, is we're going to try to learn from this and say, okay, how can we do the walls faster?
Mm-hmm.
Because the plumbing stacks that we showed the prefab, I mean, they're flying it up at like 30% the labor they used for a recent project that's basically the same size, but in concrete and was stick built. So there's been a lot of good learnings on the job for sure. Do you want to show the mechanical room? Or?
Sure. Yeah.
I think in the essence of time, we have 15 minutes. We wanted to get into a different project too, to show kind of our, we assume everyone here is pretty much CATIA power users, so we're trying to improve each time. And that wall tool, for example, we now have, I think, a better way to do it. But we will just to finish the tall wood on the mechanical room prefab stuff, and then we'll go into a different job and try to save maybe a couple minutes for questions if there are any.
All right, so a lot of people are talking about the prefab on the wood, but there is also prefab on the mechanical as well. So not only the mechanical that's linked to the wood that you saw in the sanitary drainage, but also the mechanical room. So we detailed out this mechanical room to fabrication level detail, where they're actually, I think they're building right now. And we have all of the individual components for the hot water tanks, heat exchangers, pumps, and all of each of the valves.
Tell me the colors mean.
So, and then we typed each of the systems in a different color, obviously, to kind of for clarity purposes. So we have Victaulic as well as welded systems integrated into this one model. And one of the things that we identified pretty quickly is just the size of some of these flanges coming together and then adding insulation. is a pretty big deal and a major factor in the kind of overall volume that each of these elements takes up. So we built a installation UDF, which is basically a UDF that offsets as a combination. What we've done is initially we had all these pipes, and because of the installation tool, it requires you to set up the master spec pretty much fully before you can use it to its full functionality. And even then, to be honest, it's not the best tool. So as a workaround, what we found is we can take this rigid pipe, and each rigid pipe is its own physical reference part. It's not a feature-based pipe. Not a feature-based pipe that it was in V5. So what we can do instead is extract this routable geometrical set, which is actually the geometry of the pipe as well as the center curve of the pipe, and it also hosts all the individual nodes. And that extract will give us the volume or the surface of that pipe, and then we can use an offset surface to generate the insulation. So I'm going to just, so if you need insulation on any of your piping, I don't know if any of you guys are using piping or modeling that, it's a good way to quickly add a insulation thickness to your pipes with, and it's nice because it's also pretty much it's pretty much the same thing in terms of a visualization of that part, of that insulation part. So our UDF essentially from that point just took this and automated this so that we have a UDF that does this whole operation, and then it will do it for the whole assembly. So I wanted to show more about the mechanical room, but we should show our last iteration of the drywall tool. So I'm going to jump into Vancouver Houses, which is another project. And if you saw initially in the first model we had all those drywall stud tools and the UDF from the line input. What we've done to improve that whole process, because the great thing about CATIA is you can take a tool, embed it in another tool, and then continually improve and build those tools and update and upgrade them as you need them or as you kind of improve your process. So what we've done in this tool is, I'm going to open this in its own context. We've taken the tool and we've actually associated an Excel table to it. So the Excel table is think of it as basically a wall schedule, and you input all of the different parameters of that wall schedule. So the airspace, panel thickness, the number of gyp, and each of these generates a different wall type. So in any given project, we can input this wall type for each of our projects and then reference a different sheet for each of our projects using a project name. So as you can see, it's just a design table with each of the wall types, and then there's a parameter for the project name. So in this case, it's actually generated by the sheet. So we just change the sheet, and they'll change the project name. And then, based on how you want to position your stud wall, you can either do a stud center, stud side, or the finish side. And then what we do is we take a sketch. So I didn't do the whole floor, but I just did a few outputs. And you output each of these lines and name them accordingly. So in our case, we're not designing all of the stud walls, so we actually take an overlay, a sticker overlay, and we just trace out all of the wall lines, and then we can constrain them according to the dimensions that the architect provides us. You guys are probably better off in the sense that you get to constrain them right away and you don't have to read any drawings, you create the drawings. So essentially the same methodology though. We create the center lines and then output the lines, and then we rename each of the lines. You could use a script to do this as well, but we output each of the lines with a name for each wall type. So after that's done, I'm going to show the lines. We can run the knowledge pattern, which will associate each of the lines to a UDF, and then we'll run the script to create the walls. So essentially, each of the lines is linked to a UDF with a specific name, and it's going to configure or change the parameters within the UDF to match the wall type that's in the design table.
So maybe I'll say too, from the first project you saw Tallwood there, or Brockcom, is this first time we really had a use case where we needed to detail every stud, and we did it one by one manually. Basically, it took like over a week. It was super painful and long. We said, okay, we're not going to do this again. So then we built a wall tool, which, as you kind of saw that in the mod, was this one line as an input, creates the geometry, and then you have different parameters. So then the next iteration, which we're now trying to do, is say, okay, can we have all the lines on an entire floor that are associated automatically to the wall schedule, and then all the geometry gets created at once. And this is kind of iterative process. We still have to flesh out a few things like with the door and stuff like that. But generally, this is where we're trying to head with this. And use case for us is we gotta locate canning for an entire tower in a very short period of time with walls and be able to help the drywall contractor. We don't have the time to do it manually. We have to find a way to automate.
And the nice thing about this that I guess we're not going to have time for is the next iteration. So reusing these lines for each of the stud walls, because the stud walls are linked to the center line, we actually reuse the center line for all of our MEP. So we'll locate a node or a point on that stud wall and type that for a specific riser. A specific riser stack. So each riser stack has a specific name for that sanitary stack and a size associated. I'm actually going to open up an Excel just to So the next step, and we've gotten into the first iteration where we use assembly patterns to manage this, but really the next step is to recreate a sanitary riser schematic. Excel just crashed.
It's not our day today.
Not our day for tech. Recreate a sanitary riser schematic with all of the sizes associated to each floor. And then based on the sanitary stack number, we can type that as a node, similar to what we're doing with the UDF, the tool for the UDF and the lines. So each of these lines will have a point associated to a sanitary stack, and it'll also have a circle. So when we create this, it's not just a point, sorry, it's actually a circle with a center point. And then based on the size of that, because we get plan layouts, and the plan view generally will have the size of the actual plumbing on it. So we can cross-verify by drawing the plan layout on the specific floor and sketching out all the locations of the stacks. We can cross-verify and cross-reference the size that we have from our plan view that we've drawn and copied with this schematic riser, because the schematic in mechanical is ultimately the driver of everything. So if something doesn't match on the plan view, you need to be aware of it because it's going to have an effect on from the schematic aspect, because that's what's going to drive it. So not only can we check that, but we can also instantiate the correct size of pipe. And what we do to manage this is we created the possible configurations for each size of these stacks, these riser stacks. I have an example, but it's
Usually doesn't take this long. That's crazy.
yeah. I think there's some. I had to switch to next computer, and I think it was running all night. His computer's just not as good as mine, I guess.
You've run out of memory.
Probably.
Yeah.
We're pretty close to that.
We had about like 20 models loaded at once.
Yeah, we're running at 98% memory, so
Yeah.
that's probably a good point.
We want to be aware of time. I mean, if anyone wants to hang on, we can stay. Or if someone wants to like set up another time to jam on, we wanted to. What was the thing on the facade we want to talk about? The Boolean.
Yeah. So, well, I'll probably create a video just so that we can. Sorry, we thought we could get through all of it, but there's. We could have talked about Tallwood for hours, but there's another aspect that really applies to you guys, and I don't know if any of you guys are using it yet, but we use Booleans with rules to basically manage one component family for multiple configurations of a window type. So we'll have multiple types there. So we'll have, for example, in this same Vancouver house project, we have headers that have inside corners, outside corners, multiple canning for openings for ventilation, and that's managed all in one component family so that we don't have to generate and reference multiple component families at a given time. We just use a Boolean rule to manage with if statements inside of that rule to manage each of the possible configurations, and you make one component family that drives all of those different permutations and instances of that. So we can show. Oh, there it is.
There you go.
A little bit longer than we expected it to take, but yeah, essentially it creates the walls from each of those output lines based on the name and the type driven from the design table.
Thank you, Rouse Facade over there.
So yeah, I'll jump into the main building so you can see it.
So I guess, Jonathan, I want to be aware of time. You know, maybe if you guys want to stop it there, or we can hang on tight if you will have questions, and we're not in a rush on our end. But
Yeah, I just I'll say thank you guys for this wealth of information and great presentation and really showing models. Even if the performance lags, sometimes it's a reality that we all have to deal with. When we run out of memory working with really big, smart models. So thank you very, very much. I was particularly interested, I think, because I'm familiar with your stud walls, which I find fascinating. I was really interested in the driver setup that you guys have, which looks familiar to me, even though it's maybe slightly different than how I've done it in the past, or how I've experienced it in the past. I asked all my questions while you were going. I didn't hesitate. I didn't hold anything for the end. But if anybody else has questions, and if you guys have time,
yeah,
definitely open it up to anybody else.
maybe I'll talk to you on the facade side. We knew that there's a lot of facade people on this call, so we didn't want to spend too much time on that. But when we have like a unitized curtain wall system, we've gotten a pretty good script where we can, create entire building at once. It just kind of batches it. But this is a really complicated facade assembly sequence. So we've kind of broken it down into we run a starter track, the top track, the actual panel, the cover panel, and then the soffit. So there's like a 5-step scripting process to each panel. Each floor. And then because it's got kind of more of a twisting kind of geometry.
Hey guys, this is Neil from McGrath. Just a quick question. First off, this works really fascinating. I think it's the only way to really be able to push a prefab through a kind of industry that's been resistant to being able to figure out this level of kind of coordination. So really glad to kind of see this happening on a real world project. So my question is to that end, who do you guys typically work with in engaging this kind of stuff? Is it directly with the owner or more at the kind of GC level? I mean, this is not the level of detail you're going to get to working with like a design architect, right?
Yeah, typically construction heavy. So our best clients have been vertically integrated developers or developers, owner that actually is going to have an interest in the construction, that isn't going to say, okay, isn't going to hire a lump sum GC and be like, okay, build it for me. So this project actually is one of our biggest clients. They're the developer, but they have their own in-house general contractor or CM. And it's a very good fit. They do a lot of stuff globally, very complicated buildings. And so, yeah, and then general contractors as well is, obviously if they have fixed price risk, we can help reduce the risk. And then, the mechanical or the MEP side is directly with the subcontractors. Is typically, Tallwood, we were hired by the owner because we kind of convinced them to do this like an IPD-ish type of structure. It was still design, bid, build, but we really did an integrated process where we kind of were in design, providing commentary, but we always knew we were going to take this to construction. And, what I like to say is reduce the barrier of entry with regards to technology by not requiring all the trades to have to do this themselves. They could just say, are you willing to sit with us and work with us, and we can give you the outputs that you need to build. And that's kind of how we took it on that job, on that side.
That's great. Great to see it.
Thanks. Any other questions? Another thing too for this is actually a production, and that's one thing that's I think for the whole BIM world and VDC is coordinating kind of a design model is a good first step, but you don't have all the information. You don't have shop drawings. You don't have the actual size of ducts can change. Post 100% CDs. So this is, to be clear, like that embed plan, every embed plan is coming from this model. The embeds are overlaid with ISA anchors, facade panels, riser penetrations, like everything's coming from this one model, the formwork trade through to the facade fabricator. And that's helping us kind of all get in front of some of these issues as best we can and find solutions with a final output that goes to the build. So it's, they're building from this.
Have you found the client gaining more confidence in your model since the tall wood building, and now you're almost in a higher seat of power?
Yeah, definitely. Most of our clients are like repeat. So building. It's kind of growing. Everyone's getting used to this more and more. It's a kind of a newer thing to do this, as opposed to pushing it down to the trades and saying, "You guys do. You figure it out." But I don't know if power is the word. I'd say that there's, because we're trying to collaborate. We're not trying to say we're the experts in, plumbing, but if we sit with our engineers and the plumbing 30-year veteran, it can be a very good fit to be able to use the technology in a way that really drives value to the project. So in general, yes, adoption's going up, but I don't know if it's a power necessarily. It's more of a comfort, I guess, with this.
A respect and a faith in the model.
Yeah, and actually one thing too, for anyone who's still listening, like these, so we use the script process for the facade, but the actual guardrails are just done with a knowledge pattern because they have basically rules that we can follow. So that we're just doing knowledge pattern for the actual guardrail. We haven't got the glazing on but this is where the guardrail embed shoe is going to be. We found a lot of stuff that originally there's some issues here in the corner detail. This is the scupper plan that we helped kind of figure out where it's going to go with the curbs.
It was great to get a glimpse of your rule syntax too.
Yeah, so that's what it looks like geometry wise. This is half the building, where this is to 22. I think it goes to 53 roughly. So, and the only inputs that were provided were, I believe, PDFs, 2D PDFs, right? Yeah, basically, except for the shop drawings of the facade, it was DWGs.
Otherwise, you were modeling everything off of raster dimensions. Wow.
Yes. Yeah.
Wow.
And Javi, I guess I had a quick question from, this is from Shop, John. How do you balance between, when do you make a part or when do you just keep, things inside of parts, like assembly to part? I feel you negotiate that very well and have a real handle on when, it makes sense just to do the railings as knowledge template or knowledge patterns, as opposed to, really going into the assembly level. Can you just that, or?
Mostly Nick, I guess.
Yeah, I mean, mostly Nick makes the decision on that, but as a general rule, all of our facade components are pretty much, they're pretty much going to be, if they're really heavy, they're going to be feature-based until we have to go and push to a fabrication. But some things we're doing with one of our facade fabricator clients is they keep everything in feature-based, actually. And we use, I believe it's, I'm not as well versed on it, but they have a way of extracting each of these, the data from each of the bodies for their fabrication. So you don't even have to necessarily go down to that level of each gasket being a component, for example. You can extract that data and even at a fabrication level. But in this case, we just done everything in features, just because of the size, like the size of this model and the number of units that are going in. It's
not all loaded too. We have 22, I think, stories right now. When it's fully loaded with everything, it gets pretty heavy.
And another thing you kind of have to think about is we generated all the window types using a component family. Component family, generally, I don't think you can do anything at an assembly level. So you need to. It's just much easier to manage everything with the component family as opposed to building product templates for everything to be managed at that level. So yeah, our suggestion is keep it feature based unless you need to really have every single element its own component. Even at fabrication, that might not be necessary.
Mm-hmm.
Hi guys, this is Paul from Zaha. I had two questions actually, and I have to say I was quite puzzled by what we saw today. I saw some video running on YouTube already as a teaser. I don't know if that was conscious or not, but I think there's a lot of stuff in these models, and they're really smart. And yeah, well, working for an architect, we're never going to go that far. But I was willing to know how much you guys were involved, first of all, on site. If you guys are, I don't know, if you guys are present with your model on site to help coordinating like everyday sort of montage or everyday like fuck-ups that could go on the construction site. And two would be, do you guys have hands-on machines, or how is your data extracted to go to machines? Is it again just back in 2D, or is it just directly G code and stuff, in which I don't know how far are you guys involved, or if anybody else kind of takes your model and then drives it? I mean, yeah, I remember these slides, but are you guys every day on site, or?
So, okay, I mean, I'll take the first one. You can do the second one.
Sure.
So the first step, it depends on our scope and what we're trying to, like this, the tall wood one, we were involved a lot. But the tall wood, it's really interesting when you get a giant, essentially manufacturing project. It was almost like starting with the as-built, because almost everything was being prefabricated, and even the elements that weren't, we did so much, rigorous planning and detail on it. So we were involved, like, I don't know, once a week, once every 2 weeks to site, and then we just had ad hoc type stuff. We get a call, like we gave them a model and stuff, but they said, hey, can you send us some screenshots of this, or hey, we have that formwork simulation. I don't know if we ended up showing it. The formwork simulation was a total ad hoc request. They've never done 17 stories of core before, so we just went to site, went through the requirements. So it really depends. Like the reason I showed this is this arm right here is a guy who's he's like a 50-year veteran of wastewater treatment plants. He doesn't even have a computer, and we have our surface with the CATIA model, and he's like pointing it all out. So Yes, and this is the kind of a purely prefab of most of this wastewater treatment plant. We're getting involved heavily with them on site. And then, if we're doing a scope that's more coordination related, we might not do as much on site. We're trying to catch as many issues prior to they actually build. So it really, I guess it depends. And then maybe about the information going to fabrication, you can take that one.
Yeah, so regarding information for fabrication, in the Tallwood aspect, we just provided a step file, and the fabricator, that's all they really needed to generate the G code from the step. With respect to mechanical, it's also because the people that we work with they aren't necessarily in all cases super advanced in their technologies. So in that case, we provided a 2D output. So just some drawings that I think we showed earlier. Yeah. So even the mechanical room, that level of detail, we just gave them some cut sheets for each of the spools, and they were able to pre-cut and the layout as well. So they were able to pre-cut and get a quantity takeoff for all of the components that they needed. Moving forward, we would love to get into like fabrication and having our own CNC and getting our own machines, but we're still at.
Currently, we do kind of everything up to help with the. We have manufacturing engineers in house, but we do it, and when we work with a fabricator to make it. That's kind of where we're at today.
Okay, thanks, guys.
Thank you. Thanks for your time.
This is Kyle Watson at Zaner. Have you had to do much reconciliation with your model and survey data or actual field dimensions?
Yes, actually. Do you want to show? Do you have the level 1? How you did as built in the mechanical room? So I guess while Ryan tries to show a real life, we've got a couple times like on a different tower we had like a scan. We used a point cloud scan and meshed it and put it as built next to the building next to us. We don't have our own scanner. We work with a company at times when we need to get something scanned. We're actually doing a big reno right now where, like this week, we're planning on looking at options to get a bunch of the elements of the building scanned. So in general, it depends. Maybe you can talk about what you did here with the below grade plumbing, right? Didn't you make a surface that represented the actual? Maybe made it pink where the walls actually were. Putting Ryan on the spot here. Basically, what we needed to know for prefab of the mechanical room was where the final locations ended up being, where the cans actually ended up being in the slab below the. So if I remember correctly, maybe it's not in this model. We had another surface that represented the as-built before we started.
Yeah. So basically, they provided us floor drain locations and penetration locations so that we knew where we could place our equipment that wouldn't interfere necessarily with the floor drains. So what we do is we actually create we use, I think it's engineering know-how or IP, one of those apps. Here, I'll show you which one it is. IP control. So we use IP control and I think there was a tutorial in the AEC sessions where basically we can take that entire product and create an as-built dumb solid of that model. So that's this as-built here. And that locks the geometry, and from there we basically have that as in any given time we have that as a reference, and then we can change our model, manipulate our model, and we have that as a background as well. So managing the as-built in that sense was helpful as a visual, and then we kind of since everything's parameterized, we can pretty much quickly make those modifications as we get data and info from site. So we always keep this dumb solid to make sure that we have a track of what happened and how things are different.
Yeah, it really depends. I know for your guys it's way kind of different workflow. But in this project for tall wood, let me see if it opens. Where's all levels? Do we have, here it is. So the the angles on the core. So the big risks were kind of wood, concrete to wood elements. Everything with that prefab wood was connecting to concrete. And obviously cores aren't perfectly vertical as you go up. So this is going to be heavy. Anyways, on the cores, there's angles for the CLT to sit on. And on site, they were surveying every week. And I think we were getting points that Nick would be better in our office to answer, but when they had to move an embed slightly or they had to make an adjustment, they were surveying as they went. So whether it got actually implemented back into the model specifically every time, I'm not sure, but we were aware of it. It was coming out like actual live pictures and survey data to make sure that when those CLT connects to the core, it was going to fit.
Thank you. That was excellent.
Last question. I saw when you changed your slide that you have quite a lot of licenses or a lot of functions. Do you guys pay all of these licenses, or do you have a special deal with Dassault?
So yeah, we have commercial licenses as customers. The Tallwood project, we agreed with the owner and Dassault because it was innovative. We actually started this on 2014X on the cloud. So if anyone here was using 2014X on the cloud and remembers that, it was a little challenging, we'll say. So the project came. We talked to the university, was the developer. We talked to Dassault. We said, why don't we do this as a almost like demo use case? We're going to do this whole, because we were using, actually at the time we had started on V5 as a company. So our first licenses we bought were V5 licenses, and we were kind of looking at moving to 3DX. This is one of our clients. They wanted to do this. So the Tallwood project had access to a bunch of licenses. So that's why we were able to do the Delmia for this and stuff like that. It was all part of the deal.
All right, makes sense.
Yeah, I should also clarify we're a partner with Dassault, right? So we're both a what's it called, services partner and I guess a VS partner. So we resell as well.
Which means you have access to just about every role we offer.
Right.
Yeah. One of the perks of being a value solutions partner.
Sweet.
Any other questions? If not, do you guys have anything else you want to share? Any last remarks from CAD makers?
Overall, thanks for your patience. Apologies, it was a little bit choppy at the beginning. To be honest with you, we weren't planning on showing the deck first. We were kind of scrambling, loading stuff. So we appreciate your patience there. And I just want to say that, of course, if anyone has questions in the blog post, maybe we'll put like Ryan's email, my email, and if anyone ever is interested in something, welcome to contact us anytime, and technical stuff too. So just let us know.
That's very nice of you guys, and thank you so much for the presentation. I honestly can't wait for you to come back and do this again. So just keep that in mind. You may be asked to come back and give us another detailed presentation. So
okay,
thank you.
Sounds good.
Thank you.
If we can nail this riser thing, yeah, that will be a good one. We're working on it. We're not quite there yet, but if we can get this to work, it'll be good.
That's that and the component families, and and just driving a model from a spreadsheet. That's very interesting. So great. Thank you guys, and thank you everybody for sticking around, and this video will go up on YouTube shortly.
Great.
Thanks
everyone. Have a good day.
Bye.
Yeah, thank you.
Yeah, thank you again, guys.